Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
Magnetic flux. Magnetic flux is represented by phi B. Magnetic flux is nothing but the number of lines, that is number of magnetic lines passing through a given area normally. So that is known as magnetic flux. Look at this diagram. In fact, I have navigated in terms of numbers 1, 2, 3, 4, 5, 6. Look at point number 1, that is the diagram, and point number 2, the next diagram. Now focus on the point number 1, the first diagram. Here A is the surface, a particular surface. You can call it an area in a magnetic field. In fact, these magnetic field vectors are represented as B vector here. So the magnetic field vector passing through the given area, that is A. So the magnetic vector, field vector, in fact its unit is Tesla. Magnetic field vector unit is Tesla. Look at the second diagram. What is the difference between these two? Are you able to find out the n cap in the first diagram? And this is the planar surface A. You can call it surface A, where it is a normal, the n cap is a normal to the plane surface. Are you able to understand this? And the magnetic lines are passing at an angle theta to the normal of the plane. Are you able to understand? So n cap is perpendicular to A, that you have to understand. And this theta, that represents the angle between the direction of magnetic field and the that is normal, outward normal to the area. Okay, are you able to understand this? Right. So that is called theta. Whereas here the magnetic lines are passing through the n cap. It means theta is equal to 0. So that makes the difference between these two diagrams, 1 and 2. In first diagram, there is that some angle theta between n cap and the direction of magnetic field lines, that is B vector. Whereas here it is passing along with the n cap. It means theta is equal to 0. That is angle between the direction of magnetic field and the outward normal to the area, that is theta is equal to 0. So theta is equal to 0, that you have to understand. When theta is equal to 0, magnetic flux will be the product of the magnitude of the magnetic field and the area of the magnetic field, that is B into A. Let me explain about this subsequently. Now let us follow the third point. So in the third point, I have very clearly given that B vector is nothing but the magnetic field vector. Its unit is Tesla. And A, that represents the area in a magnetic field. Phi B is the magnetic flux. Its unit is Tesla square meter, or it can also be called Weber. So from this it's obvious that 1 Weber is equal to 1 Tesla meter squared. Now let us proceed to point number 4, where I already given an explanation or a definition for magnetic flux, which is nothing but the number of lines passing through a given area normally. Okay, and you should add one more point, that is we need an expression for this magnetic flux. So magnetic flux is expressed by the integral over the area. It should be called integral over the area of the product of, in fact both of them are vectors, so it's a dot product, so scalar product. So B vector, that is magnetic field vector, dot the differential area element vector. Okay, and when we integrate over the area, it becomes BA cos theta. In fact, B and A are the magnitude of the magnetic field and the area, and the theta, that is cos of theta, that we already discussed. This theta is nothing but the angle between the direction of a magnetic field and outward normal to the area. So do you understand? And here you have to remember these terms, that is magnetic flux. What is magnetic flux? What is magnetic field? Normal to the area means what? Then what is Weber and Tesla? And you should remember 1 Weber is equal to 1 Tesla meter square. Okay, now let us proceed to the next concept, and before that I'd like to give a quiz also. Anyway, we will check later after discussing this. Now, Faraday's magnetic induction. There are 2 important laws. First law, point number 1, when phi b, what is this phi b? That is magnetic flux. So when magnetic flux of a closed circuit changes, an EMF is induced. So whenever a change is happening in the magnetic flux, there arises induced EMF. And this induced EMF lasts till the phi b. What is that phi b? Which is nothing but magnetic flux is changing. So the essential condition is for a magnetic induction, that is for an electromagnetic force to be induced, what should undergo a change? Phi b should undergo a change. So there should be some change in the magnetic flux. Okay, and this continues, that is this induction continues till the phi b is changing. When there is no change, the EMF induced is also stopped. Right. And let us proceed to the second law. Second law is nothing but the magnitude of induced EMF is given by the expression, the rate of change of magnetic flux. So in the first case, we have discussed about the need for magnetic flux change. In the second case, the rate of change of magnetic flux is responsible for the EMF, induced EMF. Okay, and in fact we can include the number of turns of coil also in this case. So let us proceed with point number 4, where I have given EMF is nothing but N into, that N represents the number of turns of coil. So N into d phi b divided by dt. That is equal to, so this N can be brought into the differentiation because that is also variable if we take like that. So d of N phi by divided by dt, right? And this d phi b divided by dt is nothing but the rate of change of magnetic flux. That is, any change taking place with respect to time can be called the rate of change. So in this case, what is changing? Magnetic flux is changed. So the rate of change of magnetic flux is introduced as d phi b divided by dt. And particularly this N phi b, that is the product of number of turns of coil, and the magnetic flux is called flux linkage. So remember that. What is flux linkage? Which is nothing but the product of N number of turns of coil and phi b, that is the magnetic flux. Now let us go ahead with a small quiz. And can you tell me what is the first fill-up? That is, a B vector is equal to what? Second question, phi b is equal to magnetic flux and it is given as Tesla meter squared. So the Tesla meter squared can also be called a dash. That is question number 2. Question number 3. Phi b is given as B into A into dash. So what is that important fill-up in question number 3? And question number 4. So theta is nothing but the angle between the direction of magnetic field and dash. There are some important technical terms you have to remember. Can you fill it up? Phi. When there is phi b becomes BA. When does phi b, what is phi b? Magnetic flux becomes, when does magnetic flux become the product of B and A only? So what is the condition? So that is question number 5, that is the fill up blank. So try to solve these questions and give your answers in the comment column. And let us proceed to the next quiz. What is the first law of Faraday's electromagnetic induction? So you had to exactly reproduce these terms. That is the sentence. Question number 2. Fill up the blank. EMF dash till the phi b is changing. Question number 3. Magnitude of induced EMF is given by the expression dash. Question number 4. What is the EMF induced in terms of number of turns of coil? Question number 5. What do you call N phi b, that is the product of number of turns of coil and magnetic flux? So try to get these answers and give in the comment box. Thank you for watching this video.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.